Hello guys, welcome back to the channel. The paper we are solving today is IGCSE Physics May-June 2024 and this is the variant 43. Now, let's start with the first question. A ball of mass 130 grams is launched from ground at an initial velocity of 14 meters per second. It decelerates until it is at rest. Now, first of all, they're asking you to define deceleration. So you can just mention it is the decrease in velocity with respect to time, or you can mention per unit time. All right. Now, the acceleration of the free fall is this much. Show that the time taken for the ball to reach height h is 1.4 seconds. So it's just like this, that they're shooting something upwards at a speed of 14 meters per second. Then when it reaches a height h, the final velocity becomes 0. And then they're asking you that the time taken is 1.54 seconds. Show how. For this, you can directly use acceleration equation. Acceleration is equals to change in velocity over time. Acceleration is 9.8. Change in velocity will only be 14. And then time. So time will be equals to 14 over 9.8. When you solve 14 over 9.8, your answer will come out to be 1.4 seconds. Alright, now calculate the height, ignore the effect of air resistance. So just try to visualize this. Initially, when you are shooting it at the bottom, it only possesses kinetic energy. But when it is at the top, and they have mentioned that it decelerates until it is at rest at height h. Means when it reaches the height h, it only has GP, gravitational potential energy, not kinetic energy, right? So we can apply energy conservation here. So the half into m into v square is equals to mgh. You can cancel m from m. V square by 2, that will be 14 squared by 2 is equals to g into h. Then h will be equals to 14 squared by 2 into 9.8. Your answer will come out to be 10 meters. Alright, and in these kind of questions, even if mass is not given, there have been some questions in past papers where mass is not given and students are confused that mass is not given, how do we solve this? Mass gets cancelled out. Alright, just trust the process. If they have not given you the mass, it will get cancelled out. Now, the ball is dropped from top of a building. Describe and explain the motion of the ball as it falls. Now, see, just think about it. When you drop something from a tower, so initially the initial velocity is 0, but it is under the effect of gravity now, right? It is under the effect of gravity now. So because of gravity, it starts to accelerate. It starts to accelerate and its speed starts to increases. But soon as you're going down, as the speed is increasing, so air resistance also increases. Then there comes a point when air resistance has increased that much so that it becomes equal to the weight. The weight which is pulling you down, now the air resistance is also equal. So at this point, we mentioned that we have achieved terminal velocity. So the net force is 0 here. And now we are moving with a constant velocity because net force is 0. So acceleration is also 0. Acceleration is also 0. I'll repeat this again. See, when you drop something, initially your initial velocity is 0, but now you're under the effect of gravity, so you start to accelerate with 9.8 meters per second square. Slowly your speed is increasing. When your speed is increasing, at the same time air resistance is also increasing, because you must have felt it on your own. If you're moving it in a car at a speed of 20 km per hour and then you're moving 40 km per hour, you feel more air resistance at higher speed, right? And then there will come a point when the air resistance is equals to weight. Then at that point you have achieved terminal velocity, net force is 0, acceleration is 0, constant velocity is there. This is what you need to write in this answer. Now, question number 2. Figure 2.1 shows a solar powered traffic warning light. Alright. The energy from the solar cell is stored in a battery. Energy stored in a battery is the chemical energy. They're asking the same to you. Name the energy stored, so chemical energy. The two lights are connected in parallel state on advantage. So the advantage of parallel connection is that if there are two appliances, if one breaks, the other one will continue to work, right? So what you can mention is that if one light breaks, light slash lamp, you can mention anything, the other will continue to work. All right, this is what you need to write. The efficiency of the solar cell is 22%. The power supplied to the lights by the cell is 15 watts. So this is the power supplied. So this is the useful power. All right. State what is meant by 22% efficiency. 22% efficiency means that the useful energy is 22% of total power output. All right. Assume we had a class of 100 minutes and out of which you only studied for 22 minutes. So what is the efficiency? 22%. Because you studied only, you utilized only 22 minutes, rest 78 minutes you were sleeping. So that is not utilized, but that is the input from my side. Input from my side is 100, but you are only utilizing 22. Now, calculate the solar power input to the solar cell. Now, just think about it. Useful energy is 22% of the total power output I have written here. That is wrong. Total power input. Right? The total given to you, out of that 22% we are utilizing. So it should be input here. Now just think about it. 22% of, so you can mention 22 by 100 of the input power is equals to 15. So now you just need to solve it. 15 into 100 by 22 will give you 1500 by 22, which should be equals to 68 watts. Alright, now if you want to use this, solve this using the general formula of efficiency, we can also do it that way. Efficiency is equals to useful over input into 100. What is the efficiency? It is 22. Useful is 15. Input is x into 100. Again, you will get the same thing. X is equals to 1500 over 22. So the same we have done here. All right. Now, state suggests two advantages of using a solar cell to power than using a mains electricity. See, there are voltage drops in mains electricity, but if we're using solar cell, voltage drop will not be there and cables will not be required. So you just mentioned that no requirement of cables from mains electricity. Then you can also mention less power loss due to voltage drop. Alright, question number 3. This is a moment of force question. Figure 3.1 shows two children balanced on a seesaw. The seesaw is of length, alright. Child B moves this much away from the pivot, and as a result, what happens is it rotates clockwise. Now they're asking you for 1 mark, why is it rotating clockwise? So you do not have to show any calculation here. You can just mention because the moment is in clockwise direction. Now, as it is increased. Alright. Now, child A puts on a backpack and the seesaw now balances. Calculate the mass of the backpack. Alright. So what I'll do is I'll take the weight of the backpack directly and let's call it x newtons. This is the weight of backpack and not the mass. Alright. Weight of bag, let's say. Alright. So it's in equilibrium. It's balances. So we can say anti-clockwise moment of force is equals to clockwise moment of force. And anti-clockwise moment must be created by the child A and the backpack. So we can say 450 into what is the distance? 1.6 plus x is the weight of a bag into 1.6. This should be equal to clockwise. and clockwise child B is rotating. What is the force? 900. What is the distance? 0.85. Make sure to mention 0.85, not 0.8. So 0.85. Now you just need to equate them. Let's write it here. 450 into 1.6 plus x into 1.6. 900 times 0.85. 450 times 1.6 will come out to be 720 plus 1.6x is equals to, how much is 900 times 0.85? It's coming out to be 765. So 1.6x is equals to 765 minus 720, which is 45. So 1.6 is equals to 45, x is equals to 45 over 1.6 divided by 1.6. So it is coming out to be 28.125. What is this? This is the weight. So now you need to divide the weight by 9.8 to get the mass, which will come out to be 2.86 kgs, and you can round it off to 266. So 2.9 kg should be your answer. All right. Using this, we got the weight. You divide weight by 9.8, you will get the mass, which is 2.9 kg. Now, the concrete floor under the seesaw is replaced with a rubber floor. Define impulse first of all. So, impulse is change of momentum, or you can mention the formula as well. Explain how the rubber floor reduces injury to the child. Now, see, just think about it. Rubber floor will be absorbing some impact, but how will it absorb? It will increase the time of contact. It will increase the time of contact. As a result, force will decrease. I'll show you how. See, force is equals to change of momentum by time. All right. Now, if the time of contact has increased, force should decrease. This is what happens with airbags as well. In cars, airbags and seatbelts are provided just because in case of there is an impact, then they will help you reduce the injury because time of contact increases, so the force experienced will decrease. All right. So you can just mention that for rubber floor, time of contact will increase, or you can mention change of momentum is there, but for longer time, which reduces the force on child, which reduces the force on child. Next question. It's a thermal physics question. 4.1 shows a stainless steel saucepan being heated on electric cooker. The saucepan contains water. State what happens to the water particles as the temperature increases. Now, temperature is directly proportional to kinetic energy, so you just need to mention kinetic energy of the particles increases. The saucepan contains this much volume of water, specific heat capacity is given, density is given. Show that the mass of the water in the saucepan is this much. You have to prove this, so you just do density is equals to mass over volume. Mass is equals to density into volume. Density is 1000. Volume is 250 centimeter cube, but make sure to convert it into meter cube before substituting. Right? So you just convert it into meter cube, your answer will come out to be 0.25 kg. Alright, this is 250 centimeter cube, so you just multiply it with 10 to the power minus 6. Will it be 10 to the power minus 6? I think so. Multiply it with 10 to the power 6, then you will get the answer. Alright. Calculate the energy required to increase the water temperature from this much to this much. So this is a specific heat question clearly. So Q is equals to mc delta T. What is the mass? We got the mass here, 0.25. Specific heat capacity is 4200. Change of temperature is 65 minus 20, which is 45. When you do the maths here, your answer will come out to be 47,000 joules. All right. Now, the heater supplies enough power to heat the water in 39 seconds. A student measures the time taken. So it's just like theoretically we are assuming it this much time it should take. It is supplying enough power to heat the water in 39 seconds if everything is good, if every condition is good. A student measures in reality, when the student is measuring, it is taking 115 seconds. So now they're asking us, why is there a difference? That 39 seconds time it should take, but in reality, when you're doing the experiment, it is taking 115 seconds. So why is there a difference? Maybe heat loss might be there, right? Otherwise, it should come out to be the same. So you can just mention the thermal energy is transferred to surroundings or to the pan, or thermal energy escapes. This is what you can mention. All right. A stainless steel saucepan is replaced with aluminum saucepan of the same mass, same volume of water. All right. But the specific heat capacity of both of them are different, right? And we know that the material with more specific heat capacity requires more energy and it takes longer time. So explain how using aluminum saucepan will affect the time taken to heat the water. First of all, it will take more time because the specific heat capacity of aluminum is higher. So more energy will be required. Remember the definition of specific heat capacity. It is the energy required to change the temperature. And if the specific heat capacity is high, it will need more energy, so more time will be required. Got it? According to the answer key, what you can mention is it will take more time because specific heat capacity of aluminum is more, and then you just mention more energy is needed to increase temperature by same amount. Let's say if you wanted to increase temperature by 50 degrees Celsius in aluminum and stainless steel, it will take more energy, more time in the aluminum. All right. Now, question number 5. Figure 5.1 shows two containers, each filled with hot water. The outer surface of metal container is hot. Explain how electrons transfer thermal energy through the metal of the container. So it's just a metal container and they're asking, explain how electrons transfer the energy. All right. So first of all, you can mention metals contain free slash delocalized electrons. Then these electrons gain energy due to vibrations of atoms, and then collision between delocalized electrons and atoms of container, atoms of metal, transfers the energy to all parts of the container. All right. The collision between delocalized electrons and atoms of metals transfers the energy to all parts. Just bear with my handwriting here. The outer surface of the non-metal container is much cooler than the outer surface of metal container. Explain why non-metal conducts thermal energy less. Because there are no free electrons. There are no delocalized electrons in non-metals. This is what you need to mention here. No delocalized electrons. Explain in terms of particles why gases are poor thermal conductors. See, for conduction, we need electrons first of all, and we need particles to be closer to each other. Right? So you can just mention particles are further apart in gases. Particles are far apart, and vibrations are not there. Vibrations not present, and collisions are very less. All right. Now, Figure 6 shows a thin converging lens used to provide a magnified image of an object AB. Now, the object is between the optical center of lens and the principal focus. So, this is the sixth case in which virtual and erect image is obtained. And it is used by magnifying glass as a case of magnifying glass. Explain the meaning of the terms principal focus and the focal length. So principal focus is where light rays converge after passing through lens. What is the focal length? Focal length is the distance between principal focus and center of lens. It is this distance. This is the focal length. Now, on figure 6.1, draw the magnified image of AB, show your working. So, in this, what you need to do is, you can draw two rays. First ray should be like this, parallel to the principal axis. Now, it converges to the principal focus like this. And one ray passing through the center undeviated like this. And you can clearly see that the distance between both of the refracted rays is increasing. So what do we need to do? We need to retrace it backwards. I'm not using a scale here, but you should retrace it backwards, and you will notice that they are meeting at some point. At that point, you need to mark this, and you can call this A dash, B dash. This is your image, and this is virtual and upright, and it is on the same side of the lens. All right. Now, were they asking anything else? Nothing else. So you'll get the marks. Question number 7 shows two charged particle plates. All right. In A part, they are asking figure 7.1, draw at least 4 field lines to show the pattern and direction of the electric field. All right. We know that electric field follows the direction of electric current. If current is from positive to negative, electric field is also from positive to negative. Now, what you need to make sure here is that they are equidistant from each other. They should be equidistant from each other. And you need to draw at least 4 of them. And just mark arrows like this. It goes from positive to negative, right? Describe the effect of a negatively charged particle placed at X. So they're just asking you, if you place a negatively charged particle here, what will happen to it? See, it's clear that it will face repulsion from the negative side and attraction from the positive side. You can just mention attractive force from the positive side of the plate. Alright, it experiences a attractive force from the positive plate. Now, during a thunderstorm, electric field is set up between cloud and the ground. Charges on the cloud and on the ground are shown. The lightning shown is this much, discharges a current of this much in this much time. Calculate the charge that flows. Alright. So we can use I is equals to Q over T. We have to find Q. So Q is equals to IT. I is 28,000. Time is 0.0012. The answer will come out in coulombs. So make sure to mention the unit. The charge will be 34 coulombs. The lightning transfers this much energy. Calculate the potential difference between base of the cloud and the ground. So you can just use, have they given us potential difference? Oh, potential difference is what we need to find. All right. Then you can use potential difference is equals to work done by charge here. Work done is the same as energy, which is 1.2 into 10 to the power 8. What is the charge? 34 coulombs. If you solve it, your answer will come out to be 3.6 into 10 to the power 6 volts. Question number 8. Figure 8.1 shows images produced by different medical scanning procedures. Define ultrasound. So ultrasound is a sound having frequency more than 20,000 hertz. So it is a sound with frequency more than 20,000 hertz. Just write it in proper words. I'm taking less time here. State how the speed of the sound compares to sound in air. So what is the difference between speed in liquid and air? Speed of sound depends upon density. It is the highest in solids, then liquids and gas. So sound travels faster in liquids. You can just mention faster compared to air. That's it. X-rays are part of the EM spectrum. State the speed. So speed is 3 into 10 to the power 8 meters per second. All EM waves have the same speed. Describe three similarities or differences between the use of ultrasound and X-rays in medical scanning procedure. So one similarity is that both are used to scan the internal body parts without needing to cut the body. So you can just mention both are used to scan or image internal body parts without needing to cut the body. All right, you get my point. Then second you can mention is it's a difference. Ultrasound is not that much harmful, but X-rays are harmful. X-rays expose you to radiation. You to radiation. All right. Then one difference is that image formed by ultrasound, images formed by ultrasound are are obtained by partial reflection, but images formed by X-rays pass through the tissue and absorbed by the bone. So the images formed by X-rays pass through the tissue and are absorbed. So this is the main difference, that ultrasound is not that much harmful because it gets reflected, but X-rays on the other hand gets absorbed and then they produce the image. All right, now next question. Question number 9. Figure 9.1 shows a mobile phone being charged on a wireless charging plate. All right, primary coil is there, so it contains a transformer. When the charging plate is switched on, there is an alternating current in the primary coil. A secondary coil is in the mobile phone. Explain how a current is produced in the secondary coil. See, first of all, alternating current is there in the primary coil. So alternating current creates alternating magnetic field. Now, this alternating magnetic field, travels through and cuts the secondary coil. As a result, current is induced in secondary coil, right? So what happens is alternating current is a current which keeps on changing direction, and as a result of it, magnetic field also keeps on changing direction. Now this alternating magnetic field travels through and it cuts through the secondary coil, and as a result of cutting through secondary coil, so due to electromagnetic induction, current is induced in the secondary coil. Now the maximum energy stored in the battery of a mobile phone is this much. All right, this much energy is stored. Show that the maximum energy is this much. So we know that 1 kilowatt hour is equals to 3.6 into 10 to the power 6 joules. And how much kilowatt hour it is? 0.012. So just multiply it with 3.6 into 10 to the power 6. Your answer will come out to be 4.3 into 10 to the power 4 joules. All right. Now you have to remember this value 1 kilowatt hour. See, what it means is 1 kilowatt hour. In a kilowatt, 10 to the power 3 watts are there. And in an hour, 60 into 60 seconds are there. When you do the maths, it comes out to be 3.6 into 10 to the power 6 joules. All right, this is why you need to remember this value and you have done the substitution. Now, the charging plate in figure 9.1 has a useful output power of 15%. The phone manufacturer claims that this battery can be charged to 50% capacity in less than 30 minutes. 50% capacity in less than 30 minutes. So let's try to figure it out whether it is true or not. Power is equals to energy over time. And energy, you have to figure out. Time is 30 minutes. So 30 times 60 you will do. Power is 15. So when you find out the energy here, 15 into 30 into 60, the energy comes out to be, let me use the calculator. So it comes out to be 2.7 into 10 to the power 4 joules. And what will be the half of 4.3? It will be less than 2.7, right? So you can just mention, since this energy is more, or you can take out the percentage as well. What you can do is 2.7 into 10 to the power 4 divided by 4.3 into 10 to the power 4 into 100. The percentage will come out to be 63%. So it is clearly charging more. So you can say, yes, this is true. Now, next question. It's a question on radioactive emission. Leaks in the underground water pipes are detected using radioactive sources. All right. Before the radioactive tracer is added to water, the detector measures the background radiation of the pipe. The background radiation is 26. All right. Define background radiation. So this is the radiation which is always present in your room, in my room, everywhere. Background radiation is present, even if a radioactive source is not there. There is always some background radiation everywhere throughout the world in the universe. So radiation always present in environment is what you can mention here, and you will get the marks. Suggest one source of radiation that may make a significant contribution to the background count rate. So they're just asking you the source of radiation which might be adding up to the background radiation. So it can be radon gas, or it can be the building material, rocks, buildings, anything you can mention, cosmic rays. A radioactive tracer is now added to the water. The counter shows the count rate and counts per minute above the leak. Determine the count rate due to the tracer. Now, just think about it. The count rate, see, detector measures the radiation, right? And in this radiation, the radiation from the tracer is also there, and the background radiation is also there. What was the background radiation? It was 26. And what is the radiation from tracer? This is what we are trying to figure out. And what is the radioactive detector is measuring? It is given here 382. Right? So it is measuring 382, out of which some is from the tracer and some is from the background radiation. So now you have to find for the tracer only. So 382 minus 26. This will be 356 counts per minute. Make sure to mention the unit. Alright. Suggest which radioactive emission, alpha, beta, gamma, is suitable for detecting the leak in the water pipe. So you can use gamma radiation here. Explanation is that the alpha and beta radiation will get absorbed and it will be very difficult to measure the difference. But with gamma, less radiation reaches the detector, so it detects. See, these kind of procedures are done to check the cracks or the holes in underground pipelines, because we cannot keep on digging and searching for holes everywhere throughout the world. That will be very difficult to do and time consuming. Instead, we use radioactive emission, and we are using gamma radiation here because alpha and beta have very less penetrative power and they will nearly get absorbed. So you won't be able to notice a difference. What we need to do is we need to notice a difference. When we notice the difference between the emission given and the emission absorbed back, when there is a difference, means there is some kind of gap there, right? So this is why using gamma radiation. Explain why the radioactive isotope must not have a very short life. It's very basic logic. It has, if it has a very short life, it will get diminished very easily. So you won't be able to measure a difference in the rate, right? So it will diminish very quickly, or you can mention difficult, and just mention and difficult to measure rate difference. Explain why the radiation isotope must not have a very long half-life. Now just think about it. If it has a very long half-life, then the radiation will stay in the water. Someone might drink it. It might be supplied somewhere. It could be anything, right? You want medium half-life so that when you're doing the procedure, the radiation is there. When you're out, when the procedure is done, the radiation is also out, right? So it contaminates water, you can mention contaminates water supply. Last question. A galaxy is approximately this much away from Earth. Scientists observe light from distant galaxy. The wavelength observed is longer. The wavelength of the observed light is longer. State the name of this effect. This is red shift. State the current estimate for Hubble's constant. You need to remember this value. It is 2.2 into 10 to the power negative 18 second inverse, or you can mention per second. Calculate the speed at which galaxy is moving away from us. We know that V naught is equals to h by d. So little bit wrong formula that I gave you here. H naught is equals to V by d. Hubble's constant is the ratio of recessional velocity with the distance, right? So h naught is equals to V by d. You rearrange it, V will be equals to h naught into d. What is h naught? 2.2 into 10 to the power negative 18. What is the distance? Have they given it to us? I think so. 1.2 into 10 to the power 26 meters. Solving this, you will get the answer to be 2.6 into 10 to the power 8 meters per second. This is the speed at which galaxy is moving away from us. 2.6 into 10 to the power 8 meters per second. The universe is very large. We are very small. Scientists have measured the speed at which distant galaxies are moving away from the Earth and their distances. These measurements suggest that all universe was once at a single point. See, it's because that the galaxies which are far away from us, they are moving at a faster pace. Let's say this is Earth and this is planet X, this is galaxy X and this is galaxy Y. So clearly galaxy Y is more far away from us and galaxy X is less far away. What we notice is that the speed of galaxy Y is more and speed of galaxy X is less as well. Alright, so you can just mention more distant galaxies are moving away faster and the universe is expanding. Universe is expanding. All right. And just take it like to be a race. Let's say there is your friend A, B, and then there is you C. You are starting a race of 1 kilometer. After 5 minutes, one of your friend is very ahead, the second friend is in between, and you are the last one lagging behind, lazy person. So now all of you started from the same point, but your friend A is clearly ahead. What does that mean? You started from the same point, your friend is ahead of you. It simply means that the speed at which he is going is faster. It is moving away from you faster, right? So more distant galaxies, the ones which are more far away, they are moving away faster. Alright, so this was the paper. We have done all the questions in this. In case of any doubts, feel free to let me know in the comments section.